Greetings, assessors of IBDC 2021. We are the builders of tomorrow, and we would love to connect with you over our latest project, ConneXions at Hougang. So what connects us? Is it the food we eat? The people we meet? Or the way we speak? Following the theme of connecting the dots, we aim to connect the community with nature through our design. At ConneXions at Hougang, we used sustainable design, DFMA, and integrated digital design to develop our building. With this focus, we hope to connect with the people around us through our building and bring the community together. Starting off with our location, we originally had 3 options to consider: Hougang, Bukit Panjang, and Orchard. Ultimately, we determined that Hougang would be the most suitable site. The site is well connected to public transport, with Hougang MRT and interchange nearby. We aimed to build our building in the heartland after studying the site. We found that we had a chance against our nearby competitors, Hougang Mall and the Midtown and Midtown residences. We also performed site analysis to study the impact of the environment on our site. The site is surrounded by a few HDB blocks, mostly from northwest to southwest. Most of them are around 12 to 16 stories. Hence, we designed our building to maximize airflow and minimize heat gain from east and west facing. For development type, we decided on a commercial and residential mixed-use development. Using Google Maps and information from the URA website, we determined our building GFA using the GPR and site area. With the URA requirement of max 40% GFA for commercial and minimum 60% GFA for residential, we determined that our commercial and residential GFA will be 13.5 thousand meters squared and 20,000 meters squared respectively. The use of Dynamo will boost the productivity of the team by generating many different designs for us to choose from. This allows us to consider which building design best fits the site and allows us to compare. By boosting the building design process, the team can move on to more important matters like PPVC module design and sustainable features. We used generative design workflows to make it easier to optimize the design, as it handles all the back-end work of generation and iteration, presenting us with a collection of optimal building design models to be used. The building model will be displayed in both Revit and Dynamo, which will enable us to use them in simulations to further optimize our building design. From the results of the analysis, the east and west facing are shaded in red, and that means that the heat gain from the sun will be higher than the north and south facing. We have also implemented mass-engineered timber as shading devices at some facades, and used vast greenery in the development to cool down the temperature of the living space. The results also show that the largest exposure shaded in orange is on the rooftop. Hence, solar panels will be placed there to harness solar energy or greenery to reduce heat absorption. The tilt angle for solar panels will be east and west facing to maximize its energy generated and its efficiency throughout the day. From the results of the airflow analysis, the northeast and southeast facing are receiving higher winds compared to the others. The residential buildings are interlaced with open terraces that allow wind to flow through the building to the next unit, common facilities, and the neighborhood. Overall, it allows the building to have the most optimized airflow on the rest of the other directions, because the air velocity in that direction is between 2.2 to 3.5 meters per second. We determined the angle of the sun throughout the day to allow natural lighting into the building. Hence, the residential building's interlacing design provides shade to the terraces and common facilities while allowing sufficient daylighting to pass through. Our commercial building also has large overhangs that provide shade to the shops while allowing daylight to pass through on facades and on the high ceilings. To introduce better collaboration in the team, we decided to use Microsoft Teams, OneDrive, and Revit Links. This allows more productivity and keeps the team more organized so that we can progress together and work more efficiently. The use of Microsoft Teams allows easier collaboration with each other virtually. It is much safer than working face-to-face and has been a great tool for us to keep track of our progress, allowing discussion to take place easily. OneDrive was the main centralized platform where all of the team members shared their files without having to reshare after editing. Next, Revit Links were used to link up the different files that we had as we proceeded to each design discipline. For instance, our MEP system is combined with 3 members' files. This will increase productivity rather than having all of the MEP done within one file. ConneXions at Hougang features a total of 23 levels, including 3 basement levels for car park and MEP systems, 3 levels for commercial shops, and 17 levels for the residential units with sky gardens. By using DFMA for our residential and commercial modules, our construction process is sped up. To design the architecture, structure, and MEP systems, we used AUTODESK Revit. The commercial design features 3 basement levels, which includes a car park with EV charging stations. There are 3 retail levels with about 80 retail and F&B outlets. Naturally ventilated shopping mall with high volume low speed fans installed improves ventilation in indoor places. And a community garden with aquaponics systems to allow intermingling with everyone that visits. The shop units are DFMA modules to reduce cost and construction time. The residential condominium features 17 levels with 71 units with 3 different housing types. There is a clubhouse with function rooms, gym, aqua gym, and rooftop barbecue lounge. Sky gardens and green corridor add some life, while the swimming pool and playground add some fun. With the help of SketchUp Exploding View, we are able to see the different parts of the DFMA modules. With better visualization of the parts that make up the different modules, we can check and see if there are any more changes that need to be made and have a clearer picture of our different PPVC modules. Basic necessities such as mechanical, electrical, and plumbing are required for a building. Once the architectural floor plan has been drawn, the mechanical, electrical, and plumbing systems were designed for the residential and commercial units using Revit. Chiller plants will be used to cool the individual shops at the commercial mall. For our building, we looked into passive and active design strategies for sustainable design. Starting with passive designs, for our commercial building, we used an open design concept. This allows for natural light and ventilation to enter the building. It also reduces the need for air conditioning, which saves costs. The use of low-E glass as a facade at the clubhouse encourages natural daylighting and reflects heat, reducing the need for artificial lighting and lowering the energy demand of the building. Adding green walls is another feature that we have implemented. Having green walls makes our building more attractive, as well as improves the air quality in the building itself as the plants filter out pollutants. Green walls also lower the ambient temperature, which makes it cooler and improves the comfort level of the occupants. Mass-engineered timber is an environmentally sustainable material harvested from sustainably managed forests. We used it as a facade for lift lobbies and staircases for structural purposes and to improve the aesthetics of the building. To help further improve the lives of residents, we can introduce a smart home system with the help of IoT. This helps to improve living conditions of the residents by incorporating smart technologies into their daily life. With the implementation of these sensors, it helps to reduce the usage of electrical power, such that ambient lights are turning off on sleep mode and there is no one using them. The commercial area is naturally ventilated, reducing the need for air conditioning. With the help of high-volume, low-speed fans, the indoor air will circulate evenly throughout, which improves the indoor air ventilation and also the thermal comfort of the occupants. Aquaponics is another sustainable feature we want to bring in. This is to educate the community on the importance of being self-sustainable. In the aquaponics farm, we will grow vegetables and rear fishes, and hold tours to teach the public on the importance of resource stewardship and being self-sustainable. Hence, this brings the community together, and everyone can learn as one. BIPV will be used to shade the aquaponics farm. On the rooftop, monocrystalline silicone-based solar cells are also used. In total, 209,235 kilowatts per year are generated, which helps to save up to 30% of energy for the building. Water efficiency technologies will be used in the building design. One example will be using automated water sprinklers for our green walls and water efficiency labeling scheme products for the commercial sector. Electrical vehicle charging stations are located in the basement car park as a way of promoting the use of electrical vehicles. One of the innovative features integrated into our building is a swimming pool air conditioning and mechanical ventilation system. This system reuses the waste heat generated from the air conditioning in the building. The heat from the refrigerant is transferred to the swimming pool with a heat exchanger. This helps to heat the swimming pool and cool the roof. By following guidelines from BCA and relevant authorities, we created modules to improve the cost, productivity, and quality of the housing and commercial units. To increase sustainability, we also used green concrete or eco-concrete to replace sand. This is because sand is limited in Singapore. By timeline and manpower saving, we're able to reduce the construction time of our building. This also helps to make the work environment more conducive and safe. In the prefab factory, we intend to use helical elevators to lift up more modules synchronously. This helps to boost productivity. To allow for easier connection, joints or junction boxes are used to connect different electrical modules. This reduces installation time. A just-in-time delivery approach will be taken for the PPVC modules to arrive at the site. By introducing JIT, we are able to cut down on the site needed to install the PPVC modules. For on-site construction, we decided to use two flat-top cranes of 40 meters in length and 100 meters in height. This will be used to install the modules quickly. Using Navisworks Manage, we are able to do clash detection with different parts that make up the building. This could be an electrical conduit clashing with an elbow pipe. Once detected, the issue can be assigned to a team member to follow up. A walkthrough was also performed to inspect and check for any errors in the building. For visualization, the Navisworks Timeliner adds a schedule simulation for the planned construction. Augmented Reality allows us to visually check the building. The model can be projected onto any flat surface. The team can then go in and visually inspect the building. Virtual reality also allows us to inspect the building visually. The team did a walkthrough by first importing the building model into VR Collab. We then went through to visually inspect as well as gain a perspective of what the building will look like. Finally, for visual rendering, we used Enscape and various assets. Throughout the project, the team experienced many challenges, whether it be learning different programs or balancing schoolwork and meeting deadlines. However, in the end, we learned to overcome them and strengthen our knowledge in IDD, DFMA, and sustainability. We are glad to do our part for the built environment.